Coastal engineers, emergency response teams, and military planners may soon have a new best friend, thanks to continued research at the U.S. Army Engineer Research and Development Center, or ERDC. For several weeks, a quadruped robot, affectionately called a robot dog, was deployed along North Carolina beaches to test its ability to navigate the unique coastline terrain, deploy advanced sensors, and collect critical landscape data.
We wanted to generally see how well it works on the coast in sandy environments and really intense heat. And then more specifically, we wanted to add a suite of sensors to it.
The SandHound Project, a partnership between ERDC and the University of Delaware, has sought to test the commercially available technology, pushing it to the limits and writing the book on how best to deploy such technology for either civil works or military missions. The research has been conducted at ERDC's Field Research Facility, or FRF, at Duck, North Carolina, a unique environment focused on coastal engineering research.
It works very well in environments with, compact, whether it be soil or like in like a city typescape or something. But on the beach, we didn't know how well it is going to work. I mean, here at the dune toe here, where it's really soft sand, sometimes it'll sink up to its elbow, but it still trucks through it. And we didn't really know how the sand would get in the joints, especially with the heat, if it would overheat. I mean, the things like military green and black. So yeah, we're writing the book on it, figuring out how well it works in these environments. And so far it's worked way better than we were expecting.
It has a lot of really cool features. So it can transition a lot of different environments where like tracked vehicles may struggle. It can also go up and down hills and up and down stairs and things like that. So it can transit over some pretty difficult and diverse terrain. Once we saw how well it could navigate and transit over the dunes and things like that, we decided to switch it up and add on some more features and more capabilities and test some different things out with the dog.
Through the test, the team used the quadruped to test LiDAR and visual sensors, comparing those to more traditional scanning systems. They also deployed SandSnap, a technology developed by ERDC that documents sand grain size and other characteristics. This data is part of an overall effort to better understand the composition of beach environments, giving military planners information on whether a particular beach could support amphibious landing operations.
Can the Army get their equipment on the beach? What are the key parameters to determining if that sand has the bearing capacity to support those vehicles? Do we need to bring in some system like submat to be able to stabilize the beach and the near shore? We're collecting data for that effort, as well as testing out the dog and its reconnaissance capabilities, all in one big combination. There's a lot of times, not just the Army, but even in like the Civil Works mission of the Corps of Engineers, where we're going into hazardous beaches that are contaminated, beaches that have debris, like post-hurricane, that kind of stuff. There's a lot of stuff in the water. There's a lot of stuff on the beach that you don't necessarily want either civilians or your soldiers to be exposed to. And be able to serve at that beach without exposing anybody to any actual physical harm.
Just as with aerial drones, quadrupeds are advancing quickly and commercial systems are becoming far more affordable and available, placing even more importance on the research into how to best use these systems in the future.
We're in it's a very exciting and nerve-wracking time to be a researcher, I think, right now. Particularly with the advances in automation, the advances in AI. I think it's all going to come together to a new, I'm not sure exactly what the future will hold, but it's definitely going to look different.
And that future is being tested today at the FRF, complete with its facilities and staff of experts, perfectly suited to test the latest advancements in coastal engineering, from the development of new wave and storm modeling to the deployment in the latest robotic and autonomous systems.
They have all the equipment I need and the support, and I mean, even here there's about 20 people here. They're all super smart. They got all their own little niches, so if I need help with something very specific, I can go find that person, get that help, understand it, and then yeah, they've been helpful across the board.
This effort was funded by the Defense Innovation Acceleration Containerized Agile Expeditionary and Rapid Beach Preparation, or CONAIR, project under Spiral 3, creating technologies for expeditionary joint logistics over the shore operations. Funding was also provided by the U.S. Army Corps of Engineers Geophysical Computational Modeling Strategic Research and Development, or GCM, to obtain terrain data when other means of data collection might be unavailable.